Welcome to the product design and development. This video is a part of a series of videos that collectively will cover product design and development course. So please make sure to check out the rest of the videos in this series. In this video, I'll introduce you to the main 4 phases of mechanical design process and a summary of what goes into each phase of the project. Taking one step back and looking at a little bit the bigger picture, this is mainly focus of this course. And these are the 4 main phases of the project that we talk about. But it's good to know as a good designer that, hey, after you're done with that last phase, your product development, what happens to this product? Then you got to think about a lot of assembly, distribution, installation, a lot of use, training, maintenance, repair, after services and all of that. But most importantly, what happens to it when it's done? If you design a cell phone, what are people supposed to do after the cell phone is obsolete or they want to get a new one or a tool? How do they discard of it? Is it a disassembly? Can they return it? Can they retire it? Can they upgrade it? So a lot of things to think about. So as a good designer, you gotta design with that in mind that, hey, this is what's going to happen to this product. So be a efficient, conscious designer and think of what is happening after this design or this product leaves my company and leaves my desk. So again, the focus of this course is these main 4 design phases that we'll see here. Don't have to worry about the product support in this one. These are again the main 4 phases: 1, 2, 3, 4. I often use keywords to kind of remember what the phases are. The phrase 1 is planning. We'll talk about what planning for what, but project definition or planning. The keyword for phase 2 that you can use is specs, because the main focus of this phase is to figure out engineering specifications. Phase 3 is conceptual design. So it's not all about concept, but that's a keyword how you can remember. Conceptual design happens in the third phase of the project, and then system level and detailed design happens in this phase of the project as well. And then lastly, product development. Again, if you want to pick just one word for it, is just make your design, make it reality, make it a physical product. So again, the planning, specs, concept, and make your product, or the official names that are listed here. We'll get into each of these in details in this course, and the steps, what to do, what are the outcomes, what are the inputs, outputs, and all of that we'll talk about in this course. So let's just have an overview of each of them one by one, starting by phase 1. Again, remember what was the keyword? Planning. That include product planning and project planning. The difference between the two is product planning is more of a big picture. For example, Apple plans in what year, what is the product that they will develop or they will release to the market. We have a case study later on in this course, SharkNinja, producer and manufacturer, designer of vacuum cleaners. They decide in 5 years they want to have these type of vacuums, handheld, cordless. In 6 years or 7 years, they want to have autonomous, AI-driven vacuum cleaners, cordless, solar powered, whatever that might be. That's a big picture planning for the product. So you identify opportunities in this one, but also you prioritize project and product that your company should focus on at this moment, and figure out the resources. These resources are for, again, which project you want to focus more on and which projects you want to focus on later. You complete a pre-project planning for each of them. You kind of develop a mission statement. After that phase, then you start planning for the process of whichever product you want to develop. So as a result of this, you might have product A, B, C, D, E, and so on. This one is going to be year 25. This is going to be 28. Both of these are going to be released in year 30, and so on. You take that product A, now you start designing, planning for the process of one of those products. So I want to be clear on the difference of this one. The product planning phase covers a lot more products and overview and big picture of the company, versus the project planning or design process planning that happens is for one specific product. And you figure out who your team is, who's going to be part of the team, what you need, what expertise you need, or what people you need. You develop your task list and sequence of the task that goes with it. You develop project schedule, which you probably know some more familiar terms such as Gantt chart, DSM, or PERT chart, and so on. We'll talk about them later. That's the schedule of the project. You estimate resources. Every time we talk about resources, that means people, time, and money. Those are the three main resources that you need to always plan for. And you, of course, have a risk plan ready for those tasks and stuff that can go wrong, and a mitigating plan, what is going to happen. So the stuff that we mentioned here, so the task list, the task sequences, the project schedule, resources, and development, those are all collectively known as project plan. The resource estimate, that one is also known as project budget, but these are all part of the project plan. And that's what this first phase of the development process is. You focus on your project plan. You develop your project plan. So output of this phase would be the project plan, but also the mission statement you develop in the first phase, which is here, mission statement would be in this part of the process. So I've tried to color code each phase. This mustard color goes with this column, and yeah, you can see number 1. So they kind of correspond with each other, the main phases. Next one, project definition phase. Do you remember the keyword for it? What was the keyword? Specs. Because the main focus here is to figure out the engineering specs. You figure out the architecture decomposition of the product into subsystems. Focus a lot is on the function and what function needs to be done. Functions of each subsystem. We do not have a design, we don't have a sketch, we don't have a solution, we don't have any of that yet. We're just thinking, okay, this product needs to fulfill these functions. You talk to the customer. Remember, design problems are the need is not clear. As I mentioned in previous videos, the customer might not even know what they want exactly. They just know, this is our problem, can you help us solve it? Based on the customer requirements, you develop engineering specification. We'll talk about this in detail and the methods and procedure and techniques that you can use. Based on the specifications and customer needs and benchmarking. So these three, benchmarking, engineering specification, and customer requirement, they all go into generating design targets. We'll talk about the difference between a design target and engineering specification, and how you can differentiate between the two and how you use each of them to design your product. Something that a lot of you might be familiar with is benchmarking. If not, this is a generic definition of benchmarking, but at every stage of the product development process, benchmarking could mean something totally different and a different purpose. But overall, benchmarking is looking at existing products, existing market, existing functionality, to whatever you are doing. Even if you are designing a totally brand new product that has never ever existed, it still has some functionality that needs to fulfill. For example, it needs to turn on if it's a device or a tool. It needs to be powered. So there are still functionality within it that already exists in other products. So you can look in every tool, every computer, every vehicle, anything that says, hey, how are those powered on? All different options that a device, a tool, a product is powered on. That's your benchmarking. So benchmark is always looking at what exists already. The output of this phase, the most important two outputs of the phase are engineering specifications. And as we talked about, design targets are the more important phases of this project. Next phase of the project is conceptual development. I want you to think for a moment and think about what is a concept. See if you can, in your head, think of a concept definition. What is a definition of a concept? If you said an idea or something like that, unfortunately, that's incorrect. And that's what we would like to kind of clarify in this class. The concept is a representation of the idea. It's a representation of the form, function, and features. We'll talk about definition of all of these later on. If you have an idea in your head, that's an idea. But if you pull out a napkin, you start drawing some sketches on a napkin, that becomes a concept. If you pick up a cardboard and hot glue gun and make some shape and form together and put it on a table, that becomes a concept. Concept is a representation of an idea. Because often I hear when I ask this question, people say, what's an idea? Just in this course and in this context that we are talking about, let's be clear about that. Concept is a representation of an idea. It's a representation of a form, function, and features of a product. Other aspect that goes into this phase, phase 3, do you remember the keyword for it? Was concept. But it's not just concept. A lot more goes into this phase of the product. The first phase is kind of concept. Concept, this one is a lot on concept. Okay, you figure out function diagram. Okay, refer to it as FD or function diagram. We'll talk about it, what it is. Based on the function diagram, you generate concepts. Many concepts. Many concepts. And you evaluate those concepts based on the specifications that you had. Phase 2 was the specs. And then you kind of select, hey, these are my top 2 concepts. This is my top 1 concept. And then you move on to the next level. In the next level, you take that concept, again, it could be in many different forms. It could be literally a napkin sketch. It could be a detailed sketch on your notebook. It could be a 3D rendering on a computer. Those are still a concept. You take that concept and a specification, then you design a detailed components, design forms and functions in this phase of the project. This is where you generate your list of materials, bill of materials. You develop manufacturing plan, you develop process plan, you figure out what kind of testing you need to do, and this is everything that goes into your detailed design and generate that package and get it ready for the next phase of the project. So the output of this phase is all of those documents that I mentioned. It could be CAD drawings, FEA analysis, a BOM, manufacturing plan, testing plan, and all of that. List of standard parts. A lot of this would be a result of this phase of the project. And then lastly, we move into the product development phase. Remember, the keyword for it was make it, build it, or manufacture it. Again, this is not exactly the only thing that happens here, but it's a good keyword to kind of remember the 4 phases of the project. You start developing your alpha and beta prototype. We have a full video on prototypes and the difference between them. But alpha and beta prototype, usually one of them doesn't use the actual process that your product is going to be made. The second one, the beta prototype, are used with the parts and with the manufacturing process, but maybe it's assembled by hand or is assembled a little bit differently. A good mistake that I always see when I ask the difference between alpha and beta prototype from students is alpha prototypes. People say, well, those are early on. Those are just proof of concept, stuff like that. That's unfortunately incorrect. Alpha prototype and beta prototype, the only difference between them is how they're made. Otherwise, they both got to be very close to your final product. After doing that, after your beta prototype, then you can start ramping up your production. It's getting the first sets of your products to customers or to your lead users. These are usually preferred customers or are customers that feel the need for a product before everybody else in the market. So again, phase 4, you're still in phase 4. Let's make it, let's manufacture it, let's build it. That's phase 4 of the project. So looking back, you start with planning, you figure out your specs, you do a concept and design, and then you make it and build your product. Throughout the process, this is something to know, a designer paradox. At the beginning, when you look at kind of how much you know about stuff, right? Knowledge about the design problem. At the beginning of the project, when you look at this axis, this is time, your knowledge is very limited, but you have a lot of freedom in making decisions, right? The more you progress, you learn more about the customer, the need they have, the specs, the limitations, what you have. Your knowledge is increasing, but as your knowledge increases, because you've already made some decisions, you're limited by what you could do with that knowledge. And that's known as designer's paradox. The more you learn, the less freedom you have to use what you're learning. And this is natural, this is totally normal. Beginning of the project, a lot of unknown, and you're learning as you are going through the design process. You can't ever wait for everything to be known day 1, day 2, or week 1, month 1 of the project and then move on. Otherwise, no product ever going to be developed and the project never going to be progressed forward. Talking about decisions. You make a lot of decisions, but also kind of looking at this curve, it's still time. Axis X is your time. So it's divided into 3 main stages. You're designing it, and then you're kind of making it, and then you're operating and figuring out what the product is doing. You make a lot of decisions early on. The decisions you make early on, you see how much it affects the cost of the product, this black line here. That's how much the decisions you make or influence of decisions. So early decisions have a great impact on the cost of the project. If you decide early on this product is going to be made out of PLA or steel, that's a decision you can make early on. That has a huge impact over the cost of the project. One is going to be more costly than another one, and so on. So this is good to know. There's a lot of unknown. You have to make a lot of decisions, but decisions have a high impact on the cost of your product. Another thing that I want to mention, kind of any design problem you work on, and this applies to pretty much anything that involves decision making. Applying for a job, accepting a job, buying a car, buying a house, buying a new tool, anything, these basic actions kind of apply with it. Remember, design problems the need is vague, so it's important to understand the problem. Ask questions. Define the problem. What is it that exactly I'm after? What is it that the customer want? Going back to the video on different types of design problems, we had that, hey, design a joint. overlapping joint, you got to ask the customer or the professor a lot of questions to clarify that. Also get to the root of the problem. Remember, expanding the problem space, root of the problem. Next is develop some measures. You already kind of know this. This is the specs. If you're buying a car, say, hey, I need no older than 2020, no more mileage than 80,000 K, no more expensive than 25,000, whatever the specs are. The specs are always something with a number. Okay, you can't say I need a car that's safe. That doesn't have a number with it, but you can say I need a car that has 5 safety features, and you can list them. It needs to have emergency brakes, backup camera, blind spot monitor, whatever that might be. So specs are always something with a number, with a unit, with a value to it. After you develop some measure, you generate some alternatives or some solutions. You go around in the local dealerships and you find 15 cars that fit your specs. If they don't fit your specs, you don't even consider them. If you see a car that's beautiful but it's 2015, it's out of your specs, you're not going to consider that. You evaluate these alternatives against your specs. Remember, all of the alternatives should already meet the specs. Now you're just comparing them. Which one meets the specs better? Which one is a better option? Which one, if both cars are 2020 and both are under 80K, which one is cheaper? So you cannot compare at this stage. It's not whether they meet spec or not. Hopefully you've done that in a step 3. Then you decide and choose the best alternative that meets customer needs, meets your specs and all of that. And one of the most important aspects, this is more important in product development and design projects. You have to communicate that to the rest of the team, company, rest of the team, company, to your manager, to your supervisor, investor, stakeholder, and the most importantly, customer. All of that, you gotta communicate that, and that communication is very, very important. So some points on that communication. A good designer, it can speak a lot of different languages. I have 4 different types of languages: semantic, graphical, analytical, and physical languages. And then each of those has different levels of abstraction. They go from abstract to concrete. So semantic language could totally be abstract and kind of in the middle and also move to concrete. Semantic is kind of verbal explanation or representation of the object or a description of an object. If you're working on a tool, the semantic language of it would be a tool that helps drill faster into the concrete. That's a semantic language, the way you are communicating a product to whoever you're communicating. Again, here's some example. For a bolt, levels of abstraction in describing a bolt. A semantic language, total abstract would be a bolt. You move more towards a concrete, you provide more explanation. Graphical language would be kind of drawing it, as you can see for the bolt example here. Again, you can be from very abstract to very concrete. Analytical language, kind of you explain some equations and some governing equations and concepts and principle that goes with it. In physical language, you can't really be abstract. You can't have an abstract physical language. You can kind of buy, build, make that part and show it. So different levels of abstraction and different types of languages that, again, you have been using this without knowing that that's called semantic language. And the name really doesn't matter much as long as you're able to use it. Here's a good example. I mean, I asked you to kind of look this up, but this is an example. You can find photos of this. So please Google this and find the actual image of them. So these are the three engineers that designed the fourth rail bridge, and they kind of demonstrated. So they build a little scale and they demonstrated how the suspension bridge works and how the counterweights work. Again, they could have put this in equations and analysis and drawings and reports, and a lot of people would have understood them, and a lot of people would have not. This way, everybody, when they look at their demonstration, everybody going, oh, I get it. So this is a very good example of an effective communication, and as an engineer, how you communicate your design, your solution, your results to the customer and to whoever that we listed. Thank you.